Hello everyone. Today I will present on variable labeling, summarizing, and data. This presentation is available on my GitHub, or you can find also at Analytics Hub. So in this presentation, I will cover all this. So as I noted, this presentation is already available online in my GitHub repository, and you can find the codes and the descriptions for each different content. So in this presentation, one of the section I will cover will be factors and variables. That means how can we change, for example, from numerical to other, for example, character or integer, and also how can we label, for example, the values and the variable names. So this is, for example, the important thing. For example, we can convert to a variable to factor, or we can as well, or we can rename factor labels. Or we can also record with cats. That means FST record, which is used to or fast reliable. We can use either of them to record or reorder variables. And the other is we can use group by for summarizing data and calculating proportions. And the other thing we will see is group by summarize are very important, and also summarize for continuous variables are very important for summarizing the data. So this is for summary, and the other is section we'll cover will be about slicing and reordering of the variables. That means we'll see arrange in descending order, slicing maximum, slicing minimum, top 10, top 5, top 6, something like that. If, for example, ask us the top 5 diseases, what are the top 5 problems, what are the top, or what are the list 2, or what are the list 5. So you have such kind of questions by managers or in any data work, you can use slice or top n, reorder your variables, and then provide that report. So let's move to the data and work with an example. So this is my data. So these are some of the libraries that's important for this section. So one of the things we will select, for example, marital status and gender for this. So one of the thing is, for example, labeling, for example, from M to male, from F to female, and from D to divorce. So can use label or a label variable using FST record, as we discussed previously, and using a mutate verb. So when we click this one, so we'll see, example, gender is female, male, marital status is married, single, divorced, widow, and we can also see, for example, male, married, when we see the top 6 observations. The other is assigning the variable values. For example, it's very important to understand the variable. For example, when we have a variable, what is gender, what's marital status in our practical thing. So to achieve this one, we use, for example, for this one, we use label, and then this is a variable name, and this is this is a data frame, this is a variable name. So this is the value for the variable. So when we open, for example, back factor, so I'll expand this one, and then when we open this one, so marital status is now changed. Marital is now changed to marital status. Gender is now changed to biological sex. So this is really important to understand, and especially if you work with a group of people, to understand what is the variable labels are. The other is also we can assign, for example, 1, 2 for a variable. So you can use these options as well. So the variable is now gender, means gender character. We'll have variable male, female, and okay. The other is, for example, if we want to remove a variable in our list, so we can use null, means variable data frame, and this is in the $sign. to access the specific variable, that means gender. If we say null, then we are technically dropping the variable gender. So when we click, for example, in here, we will not see any more gender. This is gender character, but gender has been already removed. The other option is also you can use, for example, if we want to remove, for example, marital status, you can use also just select, then we can use minus sign, and for example, marital. This is also the other option. Example, if we open now this variable, we have only gender character. So this is the option to a single variable if you don't want to anymore that variable. This is a little bit about how can we label a variable and how can we drop a single variable, or how can we example or labels for a variable. So details has been already presented in my GitHub address. You can have a look there. Now we will move to grouping and summarizing data. So grouping and summarize data, as we previously touched in brief, it is using group by summarize verbs. So example, in this variable, we want to group by year. So we have a data, then we are grouping the data by year. So our breast cancer summary by year, and now we are grouping by year, and now that we are summarizing, for example, what are the total participants, what are the total population, what is the mean screening rate. So we can use a group by verb, and then use a summary. For example, you have total population, also participants population, and mean screening rate. The other is create a vaccination, for example, pattern. Still we are using group by, but this group by has months and vaccine group. That means we are grouped by different variables. The previous one was only one by one, that means by year. Now we are by 3 different variables. And then we are counting a variable, and then we drop, since we make to the original ungroup. And for example, then by year and months, and then we go to at the end by year. So this is because there are a complex to have 3 different variables. So we are grouping and ungroup step by step to get our desired variables. So this is really important for visualization and other data presentation options. That means grouping by different variables. For example, if we want to present by year, months, and vaccine group, so this is the way we can achieve the data. So example, when we see this one, so we have now year 2024, and in months October, the vaccine group zoster, we have 1 count, over we have 15, and proportion in the month was 6.7, per year was 122, and proportion per year was 0.8%. So this is really important to understand different data, or to summarize our data using group by verb. And then after once we say group, then we will say count to the number of observations in that group. Then we say drop. That means we drop the groups to make the original observation. After that, that means we have chaining the observation. I mean to the next. So it's really important this way of presenting the data for summarizing our data, and also for visualization. This is with the previous one. In this one also we are summarizing the data by statistical areas rename by state and year. So technically in this we are also grouping the data by 3 different variables. So I want to present, for example, summarize my data by CS3, state, and by year. So at each step I have summarized. I have also calculating the screening rate, and for example, at the beginning I group by all, all and found the overall screening rate, and then to by state and year, and then at the end of the day I calculated by year. So technically it is going step by step by for example, it's also important in this idea. For example, the first one will give us, which is the smallest one, then the next one give us state level summary, which is a little bit bigger one, and the last one gives observation by year. So it will be similar with the previous examples anyways. When we see for example, the tail, so there is SCS3 which is called SWAN. In SWAN, state is Western Australia. In the year we have this number of and total population is total participants for screening were, and total population was 17,274. The screening rate was 49.3, and the population by area was 0.1. This shows how group by is really important for summarizing our data and producing a table, producing summaries as well. The other is calculating proportions. Is another presentation about calculating proportions, but this one will be very brief presentation or idea how can we use R to calculate the proportion. For example, here we are looking the participation rate, breast screening participation rate. We have total participants, total population. So using mutative, total participants, that means we have total participants here, and then we have total population here, and then divided by 100, so we'll get screening rate. So this is, as we see, for example, 56.1, 53.8, something like that. This is, for example, for this case, breast cancer screening. Sometimes we also want to weight the data. So it's really important to weight the data by certain population level. For example, in here we have total participants, we have total population, and now we are weighting the rate, screening rate by total population. That means this is the whole code. So we are waiting, for example, just I can maybe, so you can see. So we are now waiting, have rate multiplied total population, sum total population. So this weighting is really important. For example, if we are interested to see a certain state, then we can weight to the national average or other states. So this gives us more comprehensive and more normalized data compared to unweighted data. So if we want interested to weight, you can use this code for weighting data. So the weighted screening rate is, for example, 50.5, 50.8, 50.51.8, and 44.6. Then we can remove the data frames where I don't want. So this is all about group by, as well as calculating proportions and also of the data if we are interested. That means multiplied by the rate of the, for example, this is the rate of that population, to total population, and divide by sum of the population. And this is just I'm telling R to give one digit rather than giving multiple digits. The other is sourcing, which is really important in our day-to-day life. For example, if someone asks, what is the top 10? What are the top 5? Or what are the list 5? What are the list 5 cases or screening rate area? Something like that. So slicing data are really important. So in this section, we will see how can we sort the data and how can we identify top 5, top 10 cases. So, example, in this case, we're just preparing the data actually. So for sorting, for example, this in this case, we're rate 50 to 74 in descending order, and I'm sorting in descending order for rate 15 to 74. As we see here, the maximum is 80.2. The next maximum is 68.9. The next maximum, the third one is 68.4. So this is really important using sort. That means arrange. Then descending order. That means from maximum to minimum. And then the next one is the continuous variable. In this case, it is rate. So I put rate here. Now, if we went to the top 10, for example, top 10 cases. So I use slice maximum, and then order by, and then I can say rate. For example, I use the rate data. Then I can say rate is equal to n is equal to 10. That means I'm interested to see the top 10 screening cases. Now we'll see what are the top 10, that means areas, top 10 SCA3 areas. That means Cocos, Charters, Hobart. So these are the top 10 cases that have 50 to 74 having maximum or 10 screening areas. That means by SCA3 code. As we see, this is the S33 code. So this is a good option and handy option in our day-to-day activity. We can also see the top 5. That means changing to 5. Technically, it was top, but we now change it to top 5. So we are only see 5 cases. In this case, it is slice minimum because we are interested to see the lowest top 5 cases or top 5. That means areas that have grade. So we are areas that have screening rate. The screening rate is for women aged 50 to 74. So for women to 74, that have lowest screening rate or the lowest screening rate in areas where this one. Okay. Similarly, this is ranking by state. Previously, I was ranked by rate by different areas. Now I'm by state. We have different states in my data. So, for example, this one group by will be grouped by state. That means sum up by each state. And then once they sum up, then the next step will be sorting that data. That means we use arrange and then descending, then our variable name. That means rate. And by group, then because technically we have side group by, then we should ungroup the data, get our observation as it was original. So we arrange the data so that have, for example, this one is in descending order. So maximum breast cancer screening rate was observed Australian Capital Territory. So all top 10s are from ACT, which is surprising. Now I removed my data. As I previously noted, all the examples and more details of explanation presented in my GitHub repository, and you can go and jump in and you can have a look. And as I noted, this presentation is also available in Analytics Hub. So for attending this presentation, I will see you in the next presentation. Thank you.